Hello guys, welcome to the prime factorisation section of this topic. Prime factorisation is our title, and your LO is to be able to represent a number as a product of its prime factors. So here is your retrieval task. You can pause the video and give this a go for 10 minutes, see how you're getting on, see if you're improving with these skills. Okay, so here are the answers. Make sure you're marking your work. See how you're getting on compared to the last lesson. See if you're getting better at the indices questions. See if you're getting better at the volume questions, or maybe it needs a little bit more work. Pause it for 2 minutes and read through the worked solutions. Okay, so our success criteria for the day is again to know the definition of a multiple factor and a prime. That should be starting to stick now. To know the multiplication tables to a good standard, something we're always perfecting. And to know how to use index form. Again, that cropped up in your retrieval task, and it has done for a couple of weeks now. So the definitions. Prime, a number that only has two factors, one in itself. Indices. The index of a number says how many times we use the number in a multiplication. Standard index form. So this is just an example for you. 2 to the power of 3, or 2 cubed. It's the same as 2 times 2 times 2. So if you can pause the video for me and copy those definitions down, I will give you 2 minutes. Okay, so let's look at the I do. Can you copy this down, please? So let's break down 36 into its product of prime factors. That's what the example's asking for. So we use what's called a factor tree. So 36 can be broken down into 2 times by 18. 2 is prime, so we give it a red circle to know that branch is ended. So 18 can be broken down into 2 times 9. The 2 again is prime, so we circle it. The 9 can be broken down into 3 times 3. So what this tells us is that 36 is a product of 2 times 2 times 3 times 3. So that's the prime branches. In index form, we would write 36 is equal to 2 squared times 3 squared. Now pause the video, give yourselves 2 minutes to try and break down 135 into its prime factorisation. Here we go. So 135 can be broken down into 3 times 45. 3 is prime, so it ends the branch. 45 can be broken down into 3 and 15, and 15 can be broken down into 3 times 5. So there are prime factorizations for 135 in standard and index form. Some bigger numbers now. So let's try 630. So 630 can be broken down into 2 times 315. Can be broken down further into 3 times by 105. Then 3 times by 35. 5 times by 7 gives us 35. So we now have all our prime branches, which can't be broken down any further. So 23 as a product of its prime factors is 2 times by 3 squared times 5 times 7. Again, give yourselves 2 minutes to see if you can write 240 as a product of its prime factors. And here we go. 240 as a product of its prime factors would be 2 times 2 times 2 times 2 times 3 times 5. Or 2 to the power of 4 times 3 times 5. Now as you can see there are 4 2's, which is why it's 2 to the power of 4. So now, again, we're using the same skills of us understanding how to break things down into a product of its prime factors, but we're using this skill in a different way. So we're given in the question that 2 times 3 squared times 5 gives us 450. We want to use this to show 4,500 as a product of its prime factors. So we know that 4,500 is 10 times larger than 450. So we just need to multiply our prime factorisation by 10 as well to make it equivalent to 4,500. So 4,500 is equal to 2 times 3 squared times 5 squared, then times by 10. But we're not done yet because 10 isn't a prime factor. So 10 has to be broken down into 2 and 5. So finally, 4,500 is equal to 2 squared times 3 squared times 5. If you can pause the video for me now and give yourselves 2 minutes to try and complete the we do. So, quick little correction from me there. The bottom two lines are equal to 9,000, not 4,500. So, here we're trying to find the product of prime factors that are equal to 50. So we know that 450 divided by 9 gives us 50. So our prime factors, if we divide all of those by 9, then we will find out what the prime factorisation of 50 is. So I've put them in the brackets because the whole expression is divided by 9. 9 isn't prime, so we have to express it as its prime factors, which is 3 times 3, 3 squared. So we can show that the 3 squared and the divide by 3 squared eliminate one another. So 50 as a product of its prime factors is just 2 times by 5 squared. And we can quickly check that in our heads because we know that 5 squared is 25. 25 times by 2 gives us 50. If you can now pause for 2 minutes and try to calculate out what the product of prime factors that are equal to 75 is, using the fact that you were given in the top example. Okay, so let's have a look. So we know that 450 divided by 6 gives us 75. So we must divide our prime factorisation by 6. Again, I've put it in the brackets. Safe than sorry. So, breaking down 6 into its prime factors is 3 times 2. So, we can show that the 3 that we're dividing by gets rid of the squared term. We still keep the 3, but we're not multiplying by 2 3's anymore, just the 1. And multiplied by 2 also is cancelled out by our divide by 2. So we are left with just 3 times by 5 squared. Again, we can check that very quickly. 5 squared is 25. 3 lots of 25 gives us the 75. So if you can pause the video for me now and work through these examples for the next 10 minutes. I want you to write these numbers as a product of their prime factors. Okay, and here are your answers. Make sure you're correcting them. Make sure you're green penning your work. Well done for any that you're getting right. Remember, it's just a process. If you follow the I do's and the we do's and the pattern, you shouldn't have much trouble. Okay, so here's some large numbers. Again, give yourself 7 minutes to work through these. And here are the answers. They've given it in index form also. And give yourselves 5 last minutes to work through these problems here. It wants you to rewrite the following calculations to be a product of prime factors. So we have some factors, but they are not prime at present. This one shouldn't take so long. And there are your answers. Finally, some challenge questions. So again, this is using the skill that we used at the very end. So we are given the fact that 2 squared times 3 is equal to 12. Can use this information to show what 24 is as a product of its prime factors, and so on. Give yourselves 3 minutes to work through these. And there are your answers. Remember to green pen your work. Make it look nice. Presentable. And again, a moment for reflection. Well done for getting through that, guys. You can go back to the success criteria page now and reflect. What was easier? What was more challenging? What do you need to work on next time? And well done. That is the end of the lesson. Congratulations and thank you. I'll see you next time.